Okay, so a couple other little points I wanted to look at with these examples. I'm going to share my screen. Well, I can use this double one right off the bat because that sends something back. The return methods, we're getting something back. So if we just ask for that method, say double 16, it's going to send us back a 32. So normally with our return methods, we want to put that somewhere. Just a regular variable and then assign that double 16. And then it's just stored so that we can use it later, right? Like print D and get the print out of it and kind of the same result. But just the idea there of putting it somewhere. And one of the nice things about Python is we can also return more than one value at a time. So I'm going to write another function over here, define double and half. So we'll pass in some number, and here we want, and then with return, well, double's still the same, return twice as much as x, but then we can put up we can return a comma separated list of things. Return twice as much as x and return 0.5 times x. So twice as much and half as much. And in order to do that, that might be a problem if we tried to store that in just one variable, right? So whenever we bring those back, it's a comma separated return list. You can think of it that way. So we can just set up a comma separated list to return it to. So like D comma H equals double and half of 16. Then if we print out D, we get twice as much. If we print out H, we get that half amount. So just comma separate the return values if you want to do multiple returns, and comma separate the list where it is going. Otherwise, if we just bring back the results without putting it anywhere, I'll show you what we get that way. We get what's called a tuple. We'll look at those in a couple of weeks. The key thing is notice that it wrapped those in parentheses. That is something significant that I think we look at in week 5. It might be week 4. It might be next week when we look at that. But it sends back a tuple. But if we give it 2 places to put them, it's a comma separated return list. So we can just do a comma separated list of variables. So the only thing you have to watch is the order that it puts them in. There's multiple returns. The next thing, I'll take that comment out. So sometimes we might have some variables to work with, right? I'm going to set up something here of number equal 3. And we talked a moment ago about Python passes by value. So that if we called this double method and pass 3 in, it's passing in a copy of 3. It doesn't actually change that. But what happens if we try to access that variable from inside a method? Define another method, access number. So we don't need to send anything in. Y'all want to take a guess at it? Do you think we have access to it?
Possibly. I would think so. I would think so. I mean, it would kind of like call it.
Yeah, and the possibly is a great answer there. Because if I refine that question a little, do you think we have unrestricted access to that number? That's a little different, right?
Yeah.
So we can ask for it. Value equals 3 times number. And we'll return value. And this is very much related to the pass by value thing. Here we just ask for it. So unlike a stack heap diagram, all we did was look at the other spot. We didn't do anything with it. So in this case, if I rerun that, set that up where I can see both codes, and call that value. So access number, and it returned that value 3 times as much as that number. And if we ask for the variable number again, it's still set at 3. But what if instead of so we can access it, but what if we try to change it? So like number equal, I didn't mean to erase that line. Undo that. Edit. Well, I'll retype it. Value equals 3 times number. When I hit Control Z for undo, Zoom was trying to do something. Like, that's a terrible keyboard shortcut for Zoom to have. Undo should be available everywhere. So if value is 3 times a number, then maybe we change what number is. So now let's change it to 5. And I'll save and run that. So if we ask for that same value, access number, so you've got kind of a problem, a unbound local error. That's a big issue, right? And that's because this one has global scope. We can tell from the indenting level. It's all the way over at the left, which basically means we have access to that anywhere in our code. But when we got down here, we're kind of looking, it starts looking at local scope. It tries to assume, it's going to first off try to assume that where we type number is the variable number that we're starting with. So on the next line, we have an assignment for a variable called number. So it's going to assume we only want a local one inside of that method, just local scope, just only at that indenting level or beyond, and nothing out at this outer indentation level. So one way to get around that, if we want to actually refer to our thing number up here, is we can add the keyword global and just say global number. So that's basically telling it use the variable number that has global scope. So that time it worked. And if I print out number, it prints out that changed value for it. So if you do want to access a global, if you want to manipulate a global variable, you have to use the global keyword. And what I've found,
without the global number there, it would be 15. The access number call or a module.
Oh, like right here?
Yeah. So yeah. If it was like that, if it was, it would pull, even though like what I'm saying is like number is technically after the value calculation. So it'll still pull the, it'll still make number equal 5 for the calculation of value equals 3 times 5.
So not in this case, because it's an interpreted language. So it looks ahead, it does look ahead. So when it defined that method, it didn't actually run anything, but it like peeked at it and was like, okay, so that's how it defined the method. It's just like a peek. So like in a stack heap diagram, it's saying, okay, so there is this method that might be needed. Nothing's calling it yet, but I am going to need 1, two variables in there. So it's going to set up a spot in memory for two variables so that when something in the stack does actually ask for that, it'll know what to refer to. It prepares for it, but at that point, those variables are still empty. It only peeks ahead as far as like, okay, there's two, need to set aside memory for two spots in case somebody asks for that access number method.
Got it.
And then it's back to the interpreted language thing. So I'm going to clear that drawing off there. Then it's back to the interpreted language thing where it runs this line. And at that point, nothing has been assigned to number. It only, there's a spot for it, but nothing's been assigned there, so it can't actually use it. Does that clear that up, Dustin?
Yep, yep.
And so like we saw, we can access it, but we can't manipulate it unless we use the keyword global. And over the years, I've found that it's it's useful to go ahead and throw in that keyword global, even if all we're going to do is access it. So my rule of thumb is if I want a global variable, I just always use that keyword, and then I don't have to stop and think about whether I need it or not. But we only actually need that keyword if we're making changes. If we just want to know what that value is, we can access it. So I'm going to move this right down here by that in the code, just to kind of see they go together. And one more before we get into the other thing. Another keyword that we haven't used much yet is overloading. And that's where we write multiple methods of the same name, but just different ones. Because like we've seen it, our print method is overloaded, right? We have lots of different ways to print things. From the assignments I've seen, it looks like both of you two were, what you were comfortable with were different ways of using that print method. Our book really likes the one where we send things in as a comma-separated list of arguments. Personally, I like to just use regular old concatenation because that's the one that works everywhere, no matter what language we're in. I think you've been using mostly the printf, right, Jerry? The formatted printing. But we ask for that print method, and then we can do different things. And that's called overloading. So we make more than one method that has the same name, but has different parameters. And then the computer can tell which one we want based off the parameters we send it. So I'm going to do an example of overloading here with that first method. So say hi, only this time I will send in some parameters. I'll create a variable called user and just do a custom message instead of the general hello world. And again, I'll make it a void method and just kind of print out that. So hello plus whatever gets passed into that user method. I had a thought of a second variable. I want to put something else in there. Well, actually, I'm going to rewrite this because I seem to have forgotten my thought. Kind of the same thing. So I'm going to overload this say hi method, and we'll take in a value from the user, and then for a second value, time of day. And this way we have two custom greetings. So like if time of day is less than 12, we'll print good morning, user. Else, print good night, night user. Whoops, good night plus user. So does that make sense? There's two different things we can pass in. It could be, I was just making this example up quickly, so I'm going to change this and actually say morning. So we'll pass in the name of the user and the morning. So it's like we have two arguments to pass in there. But we could also, it's good to have a default value, right? Maybe, I can't think of a situation for this one that I just made up, but the point I was trying to get to is default values. We want to maybe have some sort of default value and like assume that it's morning. And to do that, when we set up our parameters, we can just set it equal to a value. So we're basically going to say it's morning unless they pass in an argument that says something different. Does that make sense? So maybe like a startup function on a computer. That may make a good example for this. We're going to assume the computer is being started first thing in the day. So by default, it's just going to say good morning and then whatever the username is. But if we wanted to say good night or good afternoon or any other things, we could build a long list there. Might as well put good afternoon in there, right? So elif, oh, whoops. I should use the notation in the textbook, right? Time of day is afternoon. It does work with parentheses as well. We can use a parenthesis instead of spaces. And that's what more programming languages do that with the if statements. That's why I sometimes accidentally type that out when I'm in a hurry. But we can say good morning, good afternoon, good evening, good night, something like that. And get a little bit of customization to that method. And the main thing I wanted to look at was this. So we can set in a default value so that we'll just assume it's morning, and then that will always be filled in. So if I run that, and now call say hi, well, if I call say hi without passing in any arguments, the method is overloaded, so it's going to see there's no arguments, so it's going to know to call this one and print hello world. Nope, it didn't like that. So that's kind of a problem, but so overloading is a big problem in Python. So we'll come back to that in a moment. I probably should have led into that a little bit better. It's an interpreted language, so it's going from top to bottom. So whenever it saw this, it overridden it repeated that name there. So we're going to talk about that a little bit later because that's an important thing. But I wanted to point out that it's not just, in most of our languages, it is just writing another name. But in Python, it's a little bit different, which we will see in detail when we get to object-oriented stuff. So if I just pass in one argument, though, there's a default, so it's going to know what the other one is, right? Where's the little prediction box? So in the prediction, we can see the user, And then our time of day by default is morning. So if we just enter the one argument, sorry, that was just a silly typo. I have to fill the value user with an actual argument. I'm going to take a step back and run this again. Run this. And now I'm going to call that method. And we can see it has a parameter user that we have to fill and not with a variable that doesn't exist. So I'm going to pass in my name. And this one has a default value. So we can just go with that default value and get the morning. But if we want another use of it, pass in my name. And if we put something else there, such as the string night, then that's going to override what is in there. So the default values are important, and that's how we set up the overloading. So in most languages, we can do this. We can just write more than one situation, right? But with Python, we actually have to use these default values in order to handle overloading and put all of our instructions here. So what I'm going to do in order to tie those two methods together, because you saw, if we try to call that original one, it's just expecting something for user. So what we can do is add in a default value for user. I'm just going to make the default, call the default one user. And then we actually have to set up the code so that this can handle more than one thing. So if it's morning and user is equal to that default value, user is not equal to that default value, then we'll give the custom message. And same thing down here. Oops. And I've been writing in C++ all weekend. I probably should have done some more practice with Python this afternoon instead of going from writing C++ all weekend right back to this. So I already put parentheses in that. So, and user. So if it's morning and the user is not the default value, we'll do that. And the user is afternoon and not the default value, which means for our good evening, we'll have to do the same thing. If time of day is evening, night, and user is not equal to that default value of user, then say good night. And then for the else, the default case, then just do the general hello world. So for right now, that's what we have to do if we want an overloaded method. But for every parameter that we need to fill in, go ahead and put a default value and then run some selections to figure out what that needs to do. Because unlike some of our other languages, Python will not just let us do multiple methods with the same name. Does that make sense? And that's how we'd set up things like the print method, so that we can overload it, but it's not really overloaded. And there's a number of things like that in Python that we call it by terms that we use in other programming languages, but it's not exactly the same the way Python handles it. We'll see a number of them when we get to object-oriented programming in week 5, I believe. So now, if we call say hi with no parameter, with no arguments to fill parameters, we get that default case. If we say hi with say a name, we get the good morning because it wasn't the default user, and the time of day, it was the default day. Or we can ask for another one where we have a name. I'll put in my name and say night. And we get those different situations. So that's kind of how we have to handle overloading in Python. It's not really overloading. It's just making the selection based off the options. And when we pass those values in, so like say hi, we have this user parameter equals user, time of day equals morning. If there's a default for everything, we can be specific about which parameter we're filling. So I'm going to skip over the user one and do time of day equals night. Oh, I was expecting it to say good night user, but I just realized I did and not equal to it. But it does it, so it just went all the way to the default case. Which means there would need to be more selection structures written there, right? So that is one of the things about Python. It's really easy to write in, but we can't just, in most of our programming languages, we can just do this. We can just say we have more than one method with the same name and call that overloading. But in Python, we don't have a good way to overload methods like that. Does that make sense?
Yep.
Yeah, so when you set up parameters, it's a good idea to go ahead and set default values for it and then figure out what you're going to do on the way through. I made a note of that, a big note in the 2 sets of lecture notes I have, and then, so I'm thinking I did that because the book didn't mention that much. But that can be a big deal in other languages, and we can use overloaded methods, but we don't really have them here. So default values on parameters. Yeah, so the takeaway from that, hopefully, is set up default values every time you put a parameter in. It will make a much bigger difference when we get to the stuff we do in week 6. So now that other thing I wanted to talk about, kind of mentioned it. I'm going to erase that first method. So we have several methods here, right? And if we wanted to let somebody else know what was going on, the textbook says just use a comment like this, right? Say put a hashtag and then describe the method. A method to output a greeting. But who's going to see that? Right? Us, pretty much the only ones that are going to see it. If we write a full piece of software and when we deliver that to the users, it doesn't give any information to the user about how to use it. For reusing these methods elsewhere, which we're going to look at last thing after we look at this comment issue, it doesn't really tell us how to use it. Well, I guess I can do that first and just use that as another reason to lead in. So we saw last week, in last week's example, and the book's already shown it up a couple times, that import method, right? We can import other things to work with. And really when we import something, it's a large file of methods like this. And we might want to know what's going on with it, right? Some sort of reference. So I'm going to pull up one of these files and look at the reference material. We're still going to we'll look at how to do that with the one we just made at the end of the evening. open up a new version of the Python shell. Whoops, I didn't mean new, I meant save. Because I still haven't bothered to memorize where Python saved that here. So I just open the shell and hit save, and that gives me the address for it. It tries to save in the default folder. So if we go in here, and whenever we import something, it's going to come in this library folder. You can see here we just have lots and lots of Python files. So where's a good one to look at? Numbers, this may have. Look at numbers. So if we open this we can just open it right with idle, like we've been seeing. They have a lot more going on in theirs. They have some classes, but you'll see it's a whole lot of functions like what we've been looking at. We're defining a function, stuff about real numbers, defining a function, and it's a whole lot of functions being defined. The calendar has stuff. Where's calendar? Open this with idle. It has some stuff that's not put into classes. So we can see these functions. Like that's the same as one of them from last year, is leap function or define leap days function. If we're going to use this, notice they didn't bother to put any comments about that function in their code. If we want to use this, we need to check the actual API. That means application programming interface. And generally we use, that refers to a language. Generally we use that to, when we're talking about the documentation for something. So like Python, calendar module, API. So somewhere, here it is, docs.python.org. So on the docs page for Python, we have the actual documentation about how to use this. It tells us what the class is, stuff about this method, iter weekdays, return an iteration of the days in the week, months, year to year. You can see there's instructions about how to use that library. So this is the actual documentation. It's a lot more useful than just a couple little codes, little comments put in our code that we'll be the only ones to ever look at. And this one, I could tell this was written in one call. They didn't sit down and write this file. They generated this. In particular, this one was from PyDocs. Did I close that already? Let me open that back up. So notice here on is leap year, the first thing they have is one of those doc strings. We talked about them briefly, the strings with 3 quotation marks. Usually at entry level, getting started in Python, we use those when we want line breaks in our code, and it'll just carry through with that string. But they don't have any line breaks, so they must add a different reason. So here on the documentation for this, if we can find that is leap year, so Control F, look for is leap. See that what they put in that doc string is what showed up on this web page. So this web page was entirely generated from the comments they put in their code, basically. They used one called PyDocs. It formats it to look like this. I was going to look at a different one here, but the same basic idea. I really like PyDocs. The only problem I have with PyDocs is it only works for Python. And there are lots of programming languages out there, right? And oftentimes we mix and match programming languages to optimize what we're doing. So a lot of projects will work with more than one language. So if we're mixing languages and wanted to use PyDocs, we'd have to use something else to document our other type of code. So one that I really like to use is called Doxygen. It's been around for a while. It's and it's continually grown and grown and grown, and it knows lots and lots of languages, including Python. So we can do our Python comments in Doxygen. So I'm gonna pull up the documentation, but it's a documentation generator, and it kind of looks like they part of testing all their code was putting their documentation together. So their site and the documentation on how to use it is huge. There's so much going on there. It can be very quickly overwhelming. So I just wanted to do a quick start, and then we'll look at the documentation. Normally I would do that the other way, except Doxygen, it's so huge. So we can just put our comments in a special way. So instead of just a hashtag and then type some words after it, we'll start with 2 hashtags, and then on the next line do 1, and then we can put some keywords. So this is like a method to greet the user, some vague description. And then this one, this method takes in 2 parameters, right? The user and the time of day. So if we want to mark those, we can use these keywords @param, short for parameter, and say what those parameters are. So like @parameter is, the parameter is called user, and this is the person the greeting is customized for. Then our other parameter will do the same thing. And all of these, this is just an encoding scheme, keywords and symbols that we use in our comments to generate a bunch of code. Use this keyword @param. The other one, time of day. I'll just put select from list. Morning, evening, or night. And just kind of give out a list and describe how to use that particular, how to use that method so that somebody can see it. So I'm going to save this and then run Doxygen, which has a bunch of command line instructions, which is another nice thing about Doxygen is it also comes with an interface to work with. Most of the other ones, so like PyDocs has to be done in the command prompt or command line if you're on the Linux, or terminal if you're on a Mac. Wherever you manually type the instructions in is where you have to do the PyDoc ones. And we can do that with Doxygen, but it also has a convenient little graphic user interface that's easy to work with called Boxy Wizard. And here we can just kind of fill out a little form and set it up for and set it up to document all our code. So on the first page, we just kind of have to select where we're going to work at. And if you're using this, one thing along the way of generating the documentation, it's going to create a bunch of temporary files and then delete them. And if any of the if you do it in the same place as your code and a name of one of your files matches the name on one of those temporary files that gets deleted, obviously both of them will get deleted because the computer can't make distinctions like that. It's going to say, okay, delete the file with this name. You're going to look around and delete the file with that name. So it's a good idea to put it, give it a working folder. So I usually just create a new folder called Scratch, just a Scratch file for those ones to get rid of. So give it some sort of Scratch folder to work in. That way it doesn't accidentally delete something else if it has the same name. And then we can give it some information, give it a name, a description, you know, version number, just some form stuff. The next required part is, where are we getting the code? Where is the code that needs documented? So here we can just search for the folder where our stuff is at. So I saved this in the delete folder. So I'll just navigate to there, say it's the delete folder. And if you have it nested in directories, like Python stuff's in one folder and C++ stuff's in another folder, but they're both parts of the same project, you would want to make sure and check the scan recursively box. And then where are we printing the output to? So select, and I'll just come up here and print output that, not to the Scratch folder. That's for the temporary ones that get created and deleted along the way of making the websites. And I'll just put it in the same folder as this, and it'll generate a large folder full of files for us. The next page, what are we documenting? All entities. We can optimize for a certain language. There's a short list here. This part doesn't really matter anymore. It used to matter a lot more than it does, but it's been adjusted over the years and constantly improved, and they just never took that out of the graphic user interface. And then here we just select the output we want. So we'll output HTML. So a web page, I'm going to turn off the search function, but we can just hit a checkbox if we want a search thing to be able to search through our website and find things. Or a LaTeX document, that's going to be a PDF with links all over and stuff. Interconnected series of PDFs. And different formats we can choose. I'm just going to do a web page here, and we hit next. We can generate some diagrams, class diagrams, which we will see next week, I think. It might be week 5. Actually, we have a homework assignment to draw class diagrams, and which are all very similar. The computer can generate class diagrams all day long, because once the class has been created, the computer can tell exactly what the diagram is going to look like. But, so that's an assignment we have in week 5, and this will just generate those for us. That's straightforward. And then eventually we hit this, we're ready to run it. So it just comes to this run thing. And it skipped over this middle tab. I wanted to point out one thing before we run this. There's some different stuff for projects, a whole bunch of things to click around in. But under input, here on file patterns, you can see the extensions for all the languages that it knows. So by default, C, a whole bunch of C stuff, Java, I's, DDLs, H's, C's, PHP, Markdown, different Markdown languages, Docs, there's Python. So it knows about Python by default. A whole bunch of languages. And notice that we have a plus button. So we can add another language. And over in the project, we can remap. We can set up mapping. So if it doesn't already know about a language we're working in, this one will allow us to add that language to the documentation. And it will work with more than one language. That's why I chose to do this instead of PyDocs. That one that we looked at was something generated in PyDocs. But once we get all that stuff set up, which for starting the basic, just start at the first page, fill out the form through the wizard, and keep hitting next until you get to the run button. You just hit run, and it'll just take a second. It'll look for that file. And when it's done, can open the web page or hit show HTML. And you can see we have this big website now, a couple links here. Here's the files that are included in it. There was only one Python file in the delete folder right now. Or under namespace, we can see the stuff about that file. So if we go in here, right now so it recognizes, see how it recognized all of our functions? But the only thing that has any information is the stuff we put that documentation to. So that say hi method, it gives us some information about it, the default values, and then those parameters I typed in there, that @param. The first word after that is highlighted in bold here, and then everything else in that line. So the first word after it's highlighted, we can see it made that bold, and then everything else in the line, it just recognized that as a normal text describing that. So sort of an encoding scheme, and same thing for time of day. We can describe what's going on with this, and then we can build up our stuff that way. Probably instead of pushing that show HTML button, I should have just went over to the folder and looked at that as well. So under documents, in the delete folder, you see here 8:06, so that was 2 minutes ago when this folder was created called HTML. And here's all the files that it just generated for us. So it just made a huge website from the code we put in our comments that gives nice formal documentation so that if somebody else wanted to use these methods, obviously not these, but if you write some better methods than these simple examples, or overly simplified examples, and somebody else wanted to use them, there'd be documentation to show what they're on. And this on return types, I don't know why I just did that. We set it up the same way. So 2 hashtags on the line, and then on the next line, 1 hashtag indicates to Doxygen this is where the Doxy comments start. So we need a description. Double the value of any number. A description of what that oversimplified example does. And in this case, well, we have a parameter we're taking in again, right? So that param called x, that is the number we want to double. Only this time we're also returning something. And our keyword for that is going to be @return. And typically for a return, I like to give the type of thing it's returning. So this is going to be either an integer or a float, right? It's kind of hard to say because if somebody passes in an integer and we double it, they're getting back an integer. But if they pass in a floating point number and we double it, they're getting back a floating point number. So that one just depends on parameter type, passed in. But a description of what it is. So it's in our, same thing we would get with normal comments in our code normally. We have that description for us or other programmers that might be looking at the code directly to see those comments, but we can take it a step further and generate the website from it. So I'm going to hit save, Control S to save that and come over here and run the Doxygen again. This time I'm going to open it from the folder. If you want to open it from the folder, look for the file called index. If you haven't had anything about HTML, when we load a file on a bunch of files on a server, the one we can access without passing in the name is going to be index. So all of our servers, the first thing they do is look for an HTML file called index. And that way we can just give the domain and don't have to say in particular what file we're looking for in like the address of a browser. we open that, so kind of the setup, and then there's lots of documentation generators, and they all follow something similar like this. We do things in the comments to generate these web pages. If I go back in here, well, now we can see there's a description on this double one. So the parameter, it went ahead and made X bold, and seems like that return thing, the return type would match nicely in bold, right? But it just sent the return as the basic description. And I'm thinking, well, personally, I'd like to see that made bold like our parameter is there. It automatically bold something. And, well, we're generating a website with it, so we can pass in HTML code. So I'd like those words to be bold, so I can just put HTML tags around it. Have you all seen HTML before? I know you have, Dustin, right?
Yep.
Yeah, so we can just put the HTML tag because we're passing this text to a website. So when the browser sees HTML tags, it'll know what to do with that. So if I save that with those tags in there and run that again, this time I'll just hit the show button. That's a little bit quicker than digging through the folders for it. And all the links are set up and everything, so we can just click our way around. And then I uncheck that box for a search feature. We could put the search feature in there so that it would search through and find all our stuff. There we go. You can see that it knew what to do with those HTML tags and made that bold, made those words bold. So we can pass in HTML with our HTML things and put in images and stuff. And then we just do that for every single method, write a little description above it for that. That close that other file. Or another one that's very popular is PyDocs. That one we looked at was done with PyDocs, where it uses a doc string and it just does what I called earlier a multi-line comment, and just does the comment as a doc string. That one we have to do from the command prompt. They don't have a nice little interface to work with. Oops, didn't mean to shake the table there. But there's different options. And I've become a big fan of Doxygen because it uses, it knows so many languages, and we can quickly map a new language if it doesn't already know it. One last thing I wanted to show about this, obviously the other examples would be kind of the same thing, right? Just this sort of comment. And there's a lot it can do, but for the most part, at least starting out with it, just a general description, the parameters being passed in, and the return, what it's returning. So I would like to see this in some of your code when you write comments. Instead of the dinky comments, write some comments that you can make some good documentation from. And then that's a website, so obviously we can access a style sheet and change the style of it and everything. Because those are just buttons, and then there's a .css file that defines what those buttons look like, so we can go in and change that if we wanted to. If you feel like adjusting all that. There's also things in the GUI where you can change options for colors and things like that. The other thing I wanted to point out is those aren't our only ones. Is if I hit show HTML again, our index page is blank, right? Seems like there should be something on that, something about the overall project. So to do that, we can use this keyword @main page. So @main page or @file, that'll put in different places of it. You may have noticed, I already closed the window, there was a button that said files. So we can also do @files and put a description there. I'm just gonna do @main page and then give a description. A class example. of syntax for methods in Python. And then that main page has some sections already built into it. So we can do @section, and one of the sections, there's going to be a description section. So @description section, and then we can give it then we name it whatever we want. I'm going to call it summary. A greeting, and something more than just that first a bit. Actually, I'm going to move that down to the summary. I'm going to cut that. I'm going to put that in the summary section. I was thinking I'd do some more. And on that main page, if we just put a space and then type some more words, class example maybe, it will know that this is a title. So @main page, and then we can throw a title in to go with it. So before I run that, if I go back to show example, so I tried to put a title up there, but we have all this big empty space. So it's basically going to, what we put on the main page is going to fill that in. Another useful one, @section author, and I'm just going to call this author. I'll stick in my name. So now if I run that generator again, it's a whole lot quicker than we could put a website together, right? It doesn't take very long to do that, but it definitely takes us more than, what was that, 10 seconds? So we can see so we can see it through in the title here. Through in that title that was put right next to the main page. So @main page, and then the title you want to show on there. The My Project thing that it put up there, that was here on the wizard. We could take that out. I'm just going to take that title out altogether. Whoops. I'm going to click run there. Run. And then after it runs, it'll just override all this code, so then we can just reload this. And kind of clear some different things out. Oh, it did. I was expecting it to clear that out. I don't know why it didn't. But we very quickly generate a website to document our code in a useful fashion. So I would like to see these type of comments in your homework assignments instead of just the short little notes. Just these things: the main page, a description section, and the author. That's kind of the header comments that I've been seeing from a lot of people anyway. I think everybody that had Lloyda Fairweather for the 120 class, right? Because that's what she always required at the very first thing in everything you turned in the 120 class. So a lot of people have just been turning that in. I would like to see it put like this, where we can make it look, put it on a web page and actually do the description. And then on any methods we write, send it, describe the parameters this way and describe the return values this way. That would be enough for the comments here, because it can do a lot. Let me open this up, and I'll just search for Doxygen. You see, there's a lot of things in their documentation. The downloads, to get involved, a huge, and it's a documentation generator, so they have a very thorough bit of documentation. different examples, things coming up. I'll just click on something. This was it. Nope, I clicked on the wrong thing. Getting started will probably have something in it. Nope. There we go, special commands. That's the link I was looking for. So here is all the instructions it actually knows. So where I was putting the @ symbol, you can type any of these words to get something specific into the web page. So like @param, there's an example of that. And notice there's more than one way it's notated. So here's the original Doxygen comments, which is very similar to a Java comment. So it'll accept both of them. But our comments in Python look entirely different. So for Python, there was a different language. I don't see a Python example on there, but there's lots and lots of stuff. You can see there's lots of keywords we can use. So I would like to see this in your code, and when you add comments into your code, go ahead and add these key symbols in to get used to these documentation generators and seeing and documenting it properly. That way, if somebody else wants to use some methods you wrote, they don't have to go look at the code and check your comments. They can go check the website, check a website for it. So 8:23. I was planning on that taking until about 8:25. So, does everything there make sense? Oh, and then, yeah, also if we use the GUI, we can save the files. So when you make the changes, you can, that's another thing about that versus PyDocs. You have to start over every time because it's in the command prompt. But with Doxygen, we can just save the files and, yeah, just some stuff to put on the main page, some sort of title, and then the description section, the author, and then any method you write, include the parameter and return type. And it's not a hard requirement, but everybody has been putting comments in their code, and I'd kind of like to see these more useful type of comments. It can be a lot. There's so much to them that might as well learn it with the programming language initially. So the other thing I was going to talk about is well, I pulled up that example of when we import a module. Basically, that's a Python file with a bunch of functions already wrote for us. And we can do the same thing when we do with the module, with the Python script we write. Notice here, I put all these functions in here, but there's nothing that starts these running. There's no initial starting point anywhere. So really what I did here was create a module so we can import that into something else and work with it. So I'll use the double in half one there. So if we're in the same folder, import method example. If we're in the same folder, we can just ask for it. So I'll just set it that way. That's kind of hard. I'm going to call that M, just to make it a little easier. Or like we saw last week, I kind of prefer the structured query language type of import. So from method example, import everything, and then we wouldn't have to type use the dot notation or anything. I'll just use what the book goes with for now. Just import method example, which is kind of a long name. I don't want to type that every time I ask for it. So I'm just going to rename it M, and that way I can ask for it. So then write some code. So like number equals, I'll just type a bunch of digits, then use that method that I just imported. So D and H are going to be assigned that method double and half that's in there. Pass in that number, and then print double the number is plus D plus and half the number is plus H. Which H and D are numbers, so I need to cast those into strings to concatenate them. Which is this we've seen before, right? I don't think in the same way as the computer needs the computer processes, so there's often some jumping around. Instead of the number, I'm just going to concatenate that in there. Double, well, I'll leave it like it was. Maybe we know what that number is. So if we save it, and as long as it's saved in the same file, we don't have to do anything special to import it. I'll call it test. But we can run this. Oh, and it hit a bit of a problem. Did y'all see what the problem was? That's one we've seen before, right?
Capital.
Almost.
Or no, that's incorrect number in the.
So it doesn't recognize double and half, right? So one thing we can check is to call up the directory and see what it does recognize. Well, this. Just kind of need that part, right? That's it's in that other module. So I have to refer to that other module. So we need M dot double and half. Oh, and notice when I put M, the little preview thing popped up all the stuff that's in that other module. So now it should run. So you have to be careful with that. That's why I usually prefer this other notation, because then we don't have to do that. If we just say from method import everything, it'll be included, and then we could leave off the M dot. But if you do like the book does, make sure you remember that we have to refer to the module first. But once we did that, you can see it called it with no problem, right? Quickly took twice as much of that number and half of that number. And if it's not in the same directory, this might look a little confusing, but I kind of want to show it. Well, there's two options. If it's not in the same directory, we can use this thing called pip that we're going to look at soon. I think the beginning of next week is when I have it on my little list. And install that into our actual Python libraries. Or we can tell our script to look somewhere else as well. So I'm going to move a copy of this script to somewhere else. Right now it's in the same folder. I'm going to hit copy and I'll just put it up here on the top level. Paste it up here on the top level. And now open that with idle. And copy of it. I'm going to put a comment in here so I don't lose track of which one's which, since I have both of them open. So if we tried to run this one, it's not in that same directory, so it's not going to be able to find him, right? So, oh, well, we got a completely different error. We got a module not found error. So it doesn't know about anything called method example. So we can either import that to our actual library, or what I think is a little bit easier is there's a module called sys, which refers to the system, and which is referring to Python. So sys.path in particular happens to be information about where Python stores the modules it knows about. And we can just do that.append. So we can add something else onto that list. And we'll add in the directory to where it's at. It's on users, Chris, documents. And we can tell it, you know, one more place to look for Python modules is in this place. And that's, oh, wait, / delete. We can look here because that's where that module is saved at, right? So we can just tell the computer, make sure you also look here. So now if hit save and run, that time it was able to find it. So I went back and forth about whether to include that tonight and decided I would. It's easiest just to save it in the same folder. Just make sure if you do that on your homework, make sure you save it all in the same folder so that they're accessible. But another one is just import sys for system. So import the system module, and then to that system module, there's a path, and append to that path the directory where your modules are at. I decided to go ahead and include it because it's really not much, and it's going to be a copy and paste of that right there. So you could type that right now and copy and paste it for the next 20 years, because the only thing that would change is the directory, and that's kind of obvious when you look at it, right? Like, oh, there's a directory, so that obviously needs to change every time we do something with it. But it's boilerplate code, so you could copy and type that down now and just copy and paste and never have to type it again, which is kind of the idea of modules, right? Right now, we're looking at this in the classroom, so we're learning it, and we have to go through some examples that aren't too overly complicated, but that's what all those modules are in that, wherever that was stored at. Let's go to C drive and users and Chris and app data, local. Oh, I thought that's where Python was, but I don't see it. Oh, wherever Python's at. Why are those not in the same place? It is not in app data. Maybe it's under. No, I have to go look for it. Where's my shell? Oh, that's not helpful. Whoops. Let's click the same button again. File, save, and it's going to documents, isn't it? Yeah, that's not very helpful. Have you all seen that? Noticed that on the update, the latest update on Windows, it puts things in front of the taskbar?
Yeah.
Isn't that really annoying?
I want to say there might be a way to get around that.
Yeah, there is, but it if you shake and move everything off the screen, it'll bring the taskbar back in there. but it treats the taskbar like another application. Well, wherever that file, wherever Python stuff was, I can get to it this way. Open a new shell. I thought it was in app data, and I tried to look, but the long address. Yeah, app data local. It's under programs. So app data local programs, and there's Python. So that's what all of these are. Things code that people have already written. So there's no need to write it. No need for the people to write the same thing over and over again. Everybody can just use the ones that are already written, and then the libraries just grow and grow and grow. And here in a couple of weeks, we're going to take a look at GitHub, which is this one that we're looking at here is just the official Python library. There are mountains of code that's already been written into modules like this one that we just did tonight, only probably much more useful things. But tons and tons of modules that have already been written that we can use. And then a lot of the tasks that we need done already written, we just ask for them by importing the module and using it that way. So let's see, anything else on my list? That's that. I'll skip that, that's confusing. A couple of things on my list had big question marks beside them because it's like, that can be a little confusing. That one I went ahead and showed because that's just boilerplate code. It's copy and paste. You can copy that example and use that forever. But some of the other ones might be a little confusing. Covered that. So anybody have any questions about those? Anything we've looked at tonight?
I was going to ask for the rest of the lessons homework, we basically have a bunch of comment parameters we got to meet, but for the assignments tonight that we turn in, is there anything specific like that we need to have in comments, or is just the basic?
Just the naming reference, the reference naming.
Oh yeah, I didn't do it last time and that was like the worst one to do it. And I was re-looking at the naming convention. Oh, you say? Well, I noticed on the first lesson, it was like I was looking through the naming conventions, and it said obviously because it was a juxtaposition.
Juxtaposition this week.
Like obviously because juxtaposition is kind of ridiculous to read in terms of like naming convention. It put it at the comment. It said at the bottom, be sure to put a comment explaining what it was.
Positional notation.
Yes, yeah. So I was like, I don't know if I did that, but
I figured out what it was. I've seen it a few times. You get used to it really quick, but 2 homework assignments isn't enough to get used to it.
So the only thing, not really necessarily comments are required for tonight, just the naming.
Just the naming conventions. Yeah, and that's not a requirement. That's just something I'm saying. I'm suggesting because it will be very useful. I think everybody's been putting comments in their code anyway, and if you do those other comments like we looked at tonight, that's why those sort of generators are why I don't make a big deal out of it. But that's something I think will be very useful for when you write your code. So that's just suggestions. Right. The only requirements are the naming conventions and a bug report on it.
Cool.
And then obviously the programs run to completion, which if they don't run, you will get a long, in the comments on the gradebook, there will be a long description of what it would take, how far you were from making it run.
Okay.
A description. A lot of times it ends up being like a single symbol. It's like sometimes you'll get weird cryptic error messages and can't tell what's going on, or it won't give an error message and just do odd things. And then it's like, okay, there's a space missing. Something should be indented. This line shouldn't be indented. There's a comma missing, which sometimes it's a really short description.
It's always like a fear of mine of like, I've submitted it. I'm like, let me download it to make sure it runs right. because I don't know if I made it. If I made like I make like little incremental adjustments. I'm like, I don't know if I saved it after that.
Oh, well, my concern is that you learn to, we learn to program well. So when I put that grade on there, if it doesn't run and I give a bunch of instructions on what it needs to make it run, you can resubmit it and then boost the grade up. Yeah, because my concern is everybody learns how to program. And sometimes it takes a couple tries, right? We might not get we might not get the understanding down by 11:59 on Monday nights. My concern is that understanding. So if you need a little more time, just let me know. But yeah, if it's not running, turn it in, and I will put comments on it, and then you can redo it and turn it back in. Just let me know if you resubmit it, because I don't always get notified of resubmissions. So if I know there's a resubmission coming, I keep a list of the ones I know are coming so that I can check for them. But yeah, if you want to fix anything and turn it back in, that's fine that's fine with me, because my concern is that you learn to do this well. Not necessarily that you learn to do it by 11:59 on Monday nights. That's just a technicality, because classrooms we're on a tight schedule. And yeah, as far as I'm concerned, we have till December 19th to learn to code. So if you want to turn it in Monday, and then, if you get it, try to do it by that deadline, because, if you get it turned in late and there's a late penalty on there, on the corrections, I will keep the late penalty on. It's just you'll get the rest of the points back. But if you turn it in on time, and 2 weeks later you figured out what went wrong on it and you turn a corrected version in, I'm still going to count it as an on-time assignment, if that made sense.
Sweet.
Yeah. The goal here is to learn to program. So the 11:59 on Monday nights is just a technicality, because we are on a very tight time schedule. I just said December 19th, which seems like a long way off, but it's going to sneak up on us quick, right? Yeah. Midterms are next week. We're almost halfway through already. Any other questions?
Nope.
All right. Well, that was everything I had on my list for this evening. And then Wednesday, we're going to look at reading files, which is really useful, because after we've looked at variables, where we put values in variables, go through the run. But when our run is finished, garbage collection takes over and we don't have those values anymore. And sometimes we want our data to stick around from run to run of the program. And yeah, I want to cover reading and writing files. The book only covers text files, but our other types of files that might be more useful are essentially the same as text files. We don't have to add it. It's like one or two other keywords, and we can do more types of files and expand what the book covers. So we'll take a look at that Wednesday, and that was everything on my list. So I will see you all Wednesday night. You guys have a great evening.
See you later.
Good night.